So in this video, I want to continue my series on the text editor in C. We had started the series by putting the terminal in raw mode. In this second episode, instead, we will deal with raw input and output. So basically, that's the idea. This is all the things that we're going to implement. At the end, we'll have this flow where we're going to enable raw mode. We're going to initialize the editor, and then we have this infinite loop where we refresh the screen and we process the keypress the keystrokes that we give to the editor itself. So, having said that, let's get started. Now, if you want to support my work, you can subscribe to my Patreon, where you'll be able to access all the source code. And if you're interested in web testing, in web application penetration testing, I've released a course on Udemy. It's called Practical Web Application Penetration Testing, where we analyze the security of a web application and we discover 40 security issues. And for each issue, we write a full proof of concept. So if you're interested in that, links in the description. Now let's get started with the code. So this was the code that we left with the other day. So the other time we left with this code. So the question then becomes, okay, how do we extend this? What do we introduce to make this better and to increase the capabilities and to deal with raw input output? So the first thing is that we will need to introduce a struct that deals with the editor. So we introduce this struct editor config, this one. But to be honest, we are actually going to introduce a new file. So instead of having just an editor.c, we're going to have an editor.h, and in this editor.h, we're going to put all the headers information. So we're going to start with the typical if not define, if not f editor.h, define editor.h, and then we're going to put end if editor.h. And then within this editor here, we're going to basically include the struct. So the editor config, the termios orig termios. So this comes from termios.h, and here we put just a pound defined for the version of the software, which in this case is going to be kilo version 0.0.1. So that's the first thing that we do in order to deal with this. So it means that here, now we don't need to, we can just remove this. And here we're just going to do include editor.h, actually with this quotes because it is in the current directory. Now, if you compile this, we just compile this as follows. We're going to get some errors because here we're mentioning orig termios, but in actuality, we have to change this with what? Termios. We have to change it with e dot orig termios. With this, we have to change. And like this, it compiles, but it still have e dot orig termios. And now it compiles as before, it works exactly as before, nothing new under the sun. So that's the first thing that we did in order to go to the next level. Now at this point we want to introduce our routine to initialize the editor, init editor here. And this is just going to initialize the struct here, and we're going to get the window size and we're going to set it. So we're going to use get window size, we're going to define this function, e.screenRows, e.screen columns, screen calls. And if this function returns -1, we're just gonna die and we're gonna say get window size like this. Okay, now let's go back to the struct. What are these variables? Like when we define a struct, we want to explain what are these different things. Now, for the cx, cy, these are gonna be the x and y coordinates of our cursor position, of our cursor. While screen rows and screen calls are going to be the number of rows and the number of columns. So basically that is the idea. So that is the idea, and this is why we need the window size. So when we initialize the editor, we need the window size. So at this point, we can say, okay, how do we handle with the window size? Like how do we get the window size? So here we can have a section of our source code where we're going to write this. Then here we have the editor functions and then the main itself. So let's write the function int get window size. So this is gonna take two pointers to an integer for the rows and a pointers to an integer for the columns, because we're gonna modify basically the editor values. So here I have this win size struct, and basically I'm gonna try with ioctl call stdout file no. And here I'm going to put this togzwinsz. So this is the classical way in which you want to obtain the size of the window. with an call to IOCTL. If otherwise, like, look, we do this call. Now, if this call fails, so if it returns -1, or we were not able to read the number of columns because or this ws underscore call is 0, in this case, so given that the IOCTL call failed, we need to get the window size in a different way. And here we basically have to handle this case. Handle this. Otherwise, if everything is fine, we can just write what was written into this struct within the pointers. So this is pretty straightforward, basically, and then we return 0. So we have to handle this hack. How do we get the window size if the call to IOCTL failed? Now let's see, for example, if it fails on our computer here. Let's see. I'm gonna do enable row mode init editor, and that's it basically. And then I'm gonna print percentage t with t screen rows screen calls. Let's say rows equal calls equal. So I'm gonna compile with make. So here I have basically a problem because I need to include a library, basically. I need to include the library. In this case, the library is, let's see, it's a sys IOCTL. So it is this one. I do make, and then I say equal. So I have to do a double equal. Okay. Then here I'm gonna just return a 0 just for clarity. Let's return -1 for error. So let's do, and it says 6795. So numbers of rows 67, number of calls 95. So basically that's the idea. And actually here, I guess, because it should actually be flipped, right? It should be flipped, I believe. Let's see. Rows, screen calls. Now if I call it, let's see, if I call it here, and I do like this, and then I do this, gonna say rows 26, calls 112. So rows are these ones, columns are these others. Okay. So that's the basic idea. So it works even without this hack. Anyways, if we were forced to have this hack, however, how would we do it? Well, we have to do it this way. So we're gonna use an hack. So to get window size, move cursor to the bottom right corner and ask for its position. So basically what we have to do is we have to move the cursor to the bottom right corner and then we have to query for its position. How do we do that? We do it by writing to the screen escape sequences. So we're gonna write to the standard output file no. We're gonna write the following escape sequence. /x1b 999c /x1b 999b. Now this thing will move cursor to bottom right position. And then here I have to put 12 because this string has 12 characters where /x is /x1b is actually 2 bytes. This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So wait a second, did I count it wrong? So this is 1, 2, no actually, no, yeah, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 bytes, by the way. So that's what we do. So that's exactly what we are doing. So I write this basically, and after, so like if this did not write, if it has written less than 12 bytes, I just have to return a -1. Otherwise, I have to return a get cursor position, rows calls. I have to return a get cursor position, and this get cursor position here, I'm going to implement it up, basically. I mean, I can also implement it down here. What is it gonna get? I'm gonna get rows and calls here, and this is gonna query for the current position of the cursor. Now, to make you understand why this works, I'm gonna do this. I'm gonna enable row mode. I'm gonna just write this thing, and then I'm gonna like just enter into this loop. Now, notice what's gonna happen. So here, let's compile and execute. So wait. So here, of course, I need a semicolon. And I think also I need it up. No, I don't need it up because, yes, I actually do need it up. No, I don't need it up because it's within a conditional. So expected before token. Where is it? Right, because I don't have this. I don't have a conditional in this down. Get control position, of course, here we have to implement this. So let's say return 0 and let's put it up because I'm using it down. So let's do like this. Make editor. Notice how basically was, okay, let me see. Let's just, I don't want to write anything actually. I just want to write anything. So I'm gonna create another terminal here. I'm gonna make an editor like here. Notice how the cursor is at the end. So at the end here, there's this cursor, which I guess I really need to read this though, because otherwise, yes. So let me write again, make, and then editor. Okay, why it doesn't work with C? Care about that. So, oh, because I have to compile it. Of course, I have to compile it. Editor. Okay, notice now that the basically, so with Q, oh, I have to disable raw mode as well. What am I doing? Of course I have to disable raw mode. Make kitty. Okay, now we are good to go. So basically with this, I'm able to move the cursor on the bottom right position. Now, does it move it right too? Is it moving it right? 99C/X 99B. So, is this the right most position you can go? I guess it does. I guess it does because of course I would have to do it for every print, like here. Before every print, I would have to do this. And indeed, notice how the things are written on the opposite sides here, which is the bottom right of the screen. So this is like a big thing just to tell you that with this write, we can tell the terminal to move the cursor in a certain position. So instead this get cursor position, what we will do is we will be able to read the current position of the cursor. Now, how does it work? Well, we have to signal to the terminal. It's sort of like we have to communicate with the terminal. We're going to say to the terminal, look, I want to see the cursor position. The terminal is going to reply to us with escape codes that contain the cursor position. So we're going to say buff32, which is our local buffer. I want an unsigned int i0. I'm going to do a write to the standard file no, to this. And I'm going to write /x1b 6n here for. If this is different 4, then I was not able to correctly write it, so I return a -1. And this escape code, by the way, is used to query terminal for cursor position, basically. So that's the idea. Now, of course, once we write this, the terminal is going to reply to us, right? And so we will need to read the data. And so what we're going to do is basically to read the data, we can do this. So look at this. Here we have this write. Here we have this write, and here we have an if. We're going to have an if. If write is less than 4, okay. Then to read the data, I'm going to do stdin file no. Then I'm going to put the pointer to the buffer position. I'm going to read one character at a time. If I don't read the character here, I'm going to break. And basically, if the ith buffer is R, I'm also going to break. So I'm going to read it until I read an R. Here I do I++, but of course this is inside a loop that goes through at most the size of the buffer. Actually, size of buff -1. And then at the end, we want the empty string for the buffer. So basically, here we are reading until we either fill up the buffer or we are reading the character R, because that's how the response plays out. So at this point, we have to ask, what did we read? Because in what we read, there should be the response of the terminal which contains the cursor position. So we say if the first byte that we read is different from /x1b, or the first byte, the second byte is different from these open square brackets, then we return -1, indicating that we did not read an escape sequence, therefore no cursor position. Because basically what we are doing here at this point, which I did not explain explicitly, but to communicate with the terminal, we are using these escape sequences that tell specific commands to the terminal, and vice versa, the terminal can talk to us, to the program, via these escape sequences, which once again encode specific information. For example, in this case here we are querying for something and then we are reading for something. Of course, if we do not read back an escape sequence, it means that the command didn't work, the query didn't work. Otherwise, read information about cursor position. Otherwise, basically, so we can say, if this is the case, else, you can say else if scanf d buff plus 2. Here I have percentage d semicolon percentage d rows calls. If this is different from 2, return minus 1. Return minus 1. Otherwise, read information about, okay, here, otherwise read information. And basically, I mean, in an else, I can also say assert 0. I guess here I can say return minus 1 general error. Actually, no, because else, if, okay, otherwise we're good, basically. Otherwise we're good, and otherwise we return 0. And here we are reading, basically, this kind of format string from this data, where we are reading 2 pieces of data, the number of rows and the number of columns. Now the return value of scanf, let's read it as scanf. So return value. On success, this function returns the number of input items successfully matched and assigned, which means that in this case, scanf is going to return true if it was able to read the rows and the columns. So we need both of them to work. And so that's how we can get the cursor position. For example, let's run this function. If we just initialize the editor, and then here we put the address for e screen rows and e screen calls, and then I'm just gonna print them out. Screen rows, e screen calls, and then we just, I mean, yeah, we can have this loop, basically. But let's say that I'm not gonna print anything in this loop. So let's do make editor. So 26112. Now this function was not probably working because I actually made a mistake here, and I wrote 1/1x, but it's actually /x1. So be careful about that. This is the correct implementation. And in this get cursor position, what we do is we query the terminal, we read the response, and we check also for errors if we did not properly read the response. Basically, that's the idea, and that's how we can use it. And here it's going to say, for example, we're going to say make, we're going to say editor, and we're going to say, look, 0, 4, 1. That's the fourth row, the first column, and then of course we print it out so it changes to handle that, basically. So that is the idea with the cursor position. So at this point, the get window size should work even if the IOCTL call fails. So that's the idea. Now, all of this was to handle specific cases. Let's now talk more in general about raw input. So to handle raw input, we need a struct, which will define all the possible keys that we can press in our editor. And in this case, we can simply define this editor key struct. It is an enum. It contains various possible values associated to numbers. And we can also define this macro control key, which is going to be used to check if a key was pressed in the combination with the control character over the keyboard. So how do we use this exactly in our implementation? Well, here, basically, what we can do is we can introduce this function. We can introduce the function int editor read key. Editor read key will not take any argument in input, and it's going to mainly be used to number of bytes read, char read, and we're going to say while n read equal read stdin file no c1, we're reading 1 byte at a time. If this is different than 1, then we say if n read is equal to -1 and then erno is different again, we say die read. So basically is if the read function return -1 or we have erno different from e again, we're gonna die out because we could not read the bytes of the function. So we can just do this. And so you can imagine this loop, try to read 1 byte. So this loop just reads a single byte. Until it reads a single byte, we keep reading. Until as long as it has problems reading a single byte, we're gonna keep reading it, right? At this point though, we have to process it, basically. So we have to process it and we say, look, here we can handle it as follows. If C is different than /x1b, that is, when input is not escape sequence, when input is not escape sequence, we can simply return it as it is. Otherwise, we have to process it accordingly. Why? Because escape sequences, as we saw earlier, they encode special meaning in the terminal. So we need to understand what kind of keys was pressed and with what kind of intention. So in this case, things become more complex. So when input is not escape sequence, I guess here we say when input is escape sequence, basically. Okay, and then we say, okay, we keep track of the entire sequence. So here we are reading more bytes, basically. And to read the bytes, we can use a simple read. We can say read. So let's do read. We do sec d0, basically. And then we say, is this different than 1? And we put it into an if. Is this different than 1? We just return this, basically. And we do it again, but this time we have to put sec0, sec_y. So if we cannot read, we're just going to return /x1b. Now at this point, if the sec0 is equal to this particular character, to the open square brackets, and like at this point we have a bunch of different cases basically, and these cases all depend on the kind of keys that is being pressed, because they have different escape sequences. Now, by the way, if you're interested in the specific escape codes being used, you can check out some kind of documentation on ANSI escape sequences. And here, for example, it tells you the different kinds of encodings and the different kinds of sequences, basically. So in our case, we're just gonna parse them, basically. We're just gonna understand, for example, in this case, we're gonna say if sec1 is greater or equal than 0, but it is less than or equal than 9. So this defines a range of escape sequence. Now at this point, we're going to read the third value. So we're going to save it in sec2. And we say if sec2 is equal to this kind of character, the tilde, then we're going to switch on sec1. So we're going to switch on sec1 and we're going to handle these cases. So here is just a matter of understanding all these different keys. For example, this is the home key and the full sequence is /x1b. 1 tilde like this, then we have 2, then we have like for example 3. So let's copy them a bunch of times. So we have 1, 3, 4, 5, 6, 7, and 8, depending on the keys we want to capture. Like for example, this is the del key, the delete key, this is the end key, this is the page up key, this is the page down key, this is the home key, and this is the end key. Actually, okay, yeah. Some have even multiple representations. So like here, just say this. You just say 3, 4, 5, 6, 7, and 8. So nothing fancy about this. It's just the way that these escape sequences are defined. So remember, this was in the if sec2 equal this tilde character. Otherwise, so we say otherwise, if sec2 is not equal to a tilde, then we switch once again on sec1, but this time we have different possibility. So this time what we have is, for example, we have case A, and we return arrow up, and this is basically the /x1ba, and we have B, C, D, we have B, C, D, and then we have H and F. So we have F, H, D, B, C. So nothing fancy, and here we say arrow up, arrow down, arrow right, arrow left, home key, another way to press the home key, and end key, another way to handle the end key. Okay, so that's the idea. Then we have another else if sec0 is equal to 0. So let's see what's up with this. So basically here is, actually let's switch this up so that we have sec0 equal to 0 is the higher one, because I think it's shorter. So here we're gonna switch on sec1 once again, and we're gonna switch on sec1 and we're gonna write case h return home key, and so this is the /x1b 0h. Actually, is it a 0? No, it's a no. It's not 0, it's a no. OH. Case F, I think it's N key OF. Else, we have to say else if, basically, and then we have to put this other block. Else if this is the case. And this else, we don't care about this other else. So that's the idea. Now, after we are done with this else if, basically, so we have this else if, we have this else. This is internal to this else if. So after this else if here, we're just gonna return /x1b, basically. It's pretty like, this function is boring to write, but it is simple. That is, let's go through it again. So this is gonna be the main function that will read the raw bytes and in return, it's gonna give us this enum, one of the values taken from this enum struct, so that we know which kind of key was pressed by the user. So here we are reading a first byte to understand if you're dealing with an escape sequence. If not, we simply return the raw byte. We don't do any processing whatsoever. This processing instead is done when dealing with escape sequences. And in particular, here we are capturing a series of escape codes. Here, for example, home key, and there are different escape codes. So we have to capture all these different representation for the escape codes. But basically that is the idea. Now let's try to make it. It works, so we did not make any syntactical error that the compiler found. So it looks good. And so that was it for the raw input. In terms of raw input, this is what we get. Now, let's do something. Let's do, basically, so we have our input loop here. We are reading a single character. Actually, let's not go through with this. Let's go it as follows. So I guess in this case here, what we are returning in this editor read key. So let's do editor read key here. Editor read key. Char C equal editor read key. And if we check Q, we're gonna break it. Okay, editor. Now let's say that I do backspace. So backspace, of course, I have to print it. I have to print it, of course, because otherwise, like, I have to print it. Let's print it as a number. Let's print it as a number because I don't want any other problem. So if I press backspace, I get 127. Now 127, if I go into my struct, notice that it is exactly backspace. Now I'm gonna press arrow left, arrow right, arrow up, and arrow down to check how it works. So I go arrow left. So wait, I'm gonna do make editor, arrow left, arrow up, arrow right, arrow down. So we have minus, okay, I think it's minus to be honest, because actually this one should be like, let's not do char, let's do int. Let's do int because of course, what's the problem? If I take it as char, here it's gonna return me the value of 1000, which goes outside the scope of a char. So let's do int. Let's do int, let's recompile and let's execute. I go arrow right, I get 1001. Arrow down, I get 1003. Arrow up, arrow left. So let's go arrow left, right, up, and down. I get these 1000s, which represent exactly what I have in this enum. Because considering the enum, here we define the first element and then the subsequent are the previous one up plus one, basically. So that's the idea. It means that we were able to get this editor key working properly. Now at this point though, what we want to do is we want to output something, right? Because we want to play around with this thing. So we want to output the rows, like an editor has to output stuff. So let's recap what we've done so far. Now this is the loop. We have introduced the functions to initialize the editor and to get the window size. For the window size, we have a little hack basing on the cursor position. And we also wrote this read editor read key. So this is the function that is used to read the raw bytes for the editor. Now at this point, we want to use those raw bytes. That is, we want to process them. And so here we can add a function editor process keypress. And here we can say, I'm gonna read the key, editor read key. I'm gonna read the key here, and then I'm gonna switch on the key that I've read, depending on the type of key. For example, so here what can I do? Well, if it is an arrow, so if it is an arrow up or arrow down, left or right, down, left or right, I'm gonna do editor move cursor with the C. And then I'm gonna break. Now this editor move cursor, of course, is something that I have to implement because it is not implemented yet. And so this one I will have to implement. And it's gonna be used explicitly to like process the key press in a way that I move the cursor with that key. So that's the first thing. Then, for example, I can hit a bunch of like, I don't know, the home key should return me to the start of the row. So I'm gonna do Cx equals 0. Now why Cx equals 0? Because remember Cx is the cursor position. Now the cursor position is the specific element of the terminal that I am currently at. For example, where I will write the next character, to give an example. So when I hit the home key, I want to reset this back to the start. Now in this screen, you have to consider X is on this and Y is on this axis. And when I increase X, I'm moving to the right. When I'm decreasing X, I'm moving to the left. When I'm increasing Y, I'm moving down. And when I'm decreasing Y, I'm moving up. That is because here we have the corner 0, 0. So that's the idea. Now, another thing that I could handle, is, for example, the control key Q. And in this case, what I want to do is I want to break, and so basically I want to break from the cycle, and also I want to clear the screen. And to clear the screen, I can write to the standard output, I can write this escape sequence /1b 2j, so this is 4 bytes, and then I just want to write h, and these are 3 bytes. This is gonna clear the screen and move the cursor to the beginning. So basically that is the idea. And here I can also say disable row mode, and I can just exit the program with 0. So I don't even need to break itself because I'm just gonna exit. But I'm just gonna put it just to be on the safe side. So that could be an idea. Here I have the home key. For example, like I have the N key. Now the N key should do the opposite of the home key. So instead of resetting it to 0, I'm gonna reset it to the max value, which is screen calls -1. So that's another idea. Then, and for now, I guess we're good like this. We're good like this for now. Now, how do we put this? And by the way, okay, here to actually finish this, I have to implement this editor move cursor. So let's implement this editor move cursor. So this function specifically will deal with the following key cases. We have the arrow left, right, up, down. So right, up, down. And for each of these cases, I'm gonna say, if I move to the left, I want to decrease the cursor on the x side, the x coordinates of the cursor, because I'm moving to the left, right? So this x is gonna be decreased. But I have to be careful. I can only do that if I did not reach the edge. So if I don't reach the edge, I can do it. Otherwise, I cannot. And then I break. And here, let me just put these curly braces to be sure, basically. Here I'm gonna do something similar, but of course it's gonna be different. Now if I move right, I actually want to increase the x coordinates of the cursor, but here I want to make sure that I'm not at the right edge. So this is different than screen calls -1. Now for this instead, it is for up, I want to decrease y. For down, I want to increase y. And for up, I want to make sure that y is different than 0. For down, I want to make sure that y is different than screen rows -1. Screen rows -1. And so basically that is the function. This function is specialized for cursor movement. Now if I do make, notice no problem whatsoever, but let's actually implement this. I mean, let's say editor process keypress. So here I'm gonna say editor process keypress, basically. And here, yeah, let's just do this. So if I do make, and then I do terminal, editor, sorry. And here basically what's gonna happen, so, because here I don't print anything actually at this point. I just have the process of the keypress, but I'm not printing anything. So at this point we need to print out something on the screen to make sure that we get some output. So at this point we are about to finish off, but we actually got no output. So let's put some output on the screen. So let's deal with row output. So this is all the row input section, and let's write now the row output section. So row output, let's put row output. Here we put row input, here row input. Here we have the terminal stuff, terminal config, whatever. And here we have the editor. Here we have editor. Okay, so what do we need for row output? Well, there is one thing that we need for row output before even beginning, and this is a helper struct, which we're gonna call an ABuff. Now, what is an ABuff? Basically, this is a very simple append buffer. We will use this stuff when we have to write a lot of strings to the standard output. Now, instead of doing a lot of writes, and why is this a problem? Because it could increase the latency because we have to write a lot to the output. What we're gonna do is we're gonna append to this string, to this append buffer, and then we're gonna flash the string and we're gonna write it once. So basically we're gonna reduce the number of writes that we do. So to this end, we have two functions of interest, which is append and ab3. So ab_append takes a pointer to the ABuff struct, takes basically a new string to append it to the ABuff with the length. So here we are checking the previous length, we are reallocating the memory so that we increase the size to account for the new string. If we have a problem, we return, otherwise we're gonna basically copy this string in the memory. We're gonna append it at the end. So look at this, we do a memcopy of the string of this length of bytes starting from this address, which is the first writable new byte of the previous append buffer. So that's the idea. And then of course, we have the new buffer and we increase the length clearly. So that's a simple append, and then this is a simple free that simply wraps over the normal malloc free, like the free of the standard C library. Okay, now that we have introduced this simple append buffer, let's write the main function in this context. So it's going to be called editor refresh screen. And this function, by the way, is going to be called in the main loop. So this one is going to be called down here. I'm going to call it, so this is going to be the main loop at the end of our process. So here we have enable raw mode, here we have init editor, here we have editor process keypress and editor refresh screen. And actually here we don't even need to do disable raw mode necessarily, because actually what we can do is we can say when we enable raw mode, so here we can say, we can write this. So we can say at exit, we can say disable raw mode. So at the exit of the program, we're gonna disable the raw mode. And here we add it here, so we can remove it from this. Let's see, by the way, if this works. So at exit, okay, no, it's at exit all lowercase. Here it also wants us to include a string.h for the mem copy, clearly, makes sense. Include string.h. Okay, here we have the make, and here if I do editor and then I quit, it works fine. So basically, at the end, this is gonna be the main loop. We enable raw mode, we initialize the editor, we have this main loop where we process the key press and we refresh the screen. So raw input, and this is raw output. Now, how do we write this function basically? So editor refresh screen. Now the refreshing of the screen will use the struct that we mentioned so far, this append buffer, in the following way. So we're gonna first define a local append buffer, and we're gonna define it to the initialized one, above init. Then we're gonna append some escape sequences. So this escape sequence is used to hide the cursor. Then, so like this is hide the cursor. Then we do another escape sequence, which instead is used to move the cursor to the initial position, 1BH, and this is 3, move cursor 0, 0, because that's when we're gonna draw from the position 0, 0. Then we're gonna draw the rows, gonna do AB. So like here, draw content of screen, basically, draw content on screen. And then at the end of the day, we're gonna move cursor position to editor cursor. So since here we have moved the cursor to the position 0, 0, now we have to reset it. So this time we have to tell to write to that particular position. So we're gonna do this with this. We create a local buffer, we populate this local buffer, size of buff, with this string. So this is the escape sequence that's going to be constructed by this sn print here. It's going to be ec1 plus 1, ec6 plus 1. So the plus 1 is because the terminal coordinates are start at 1, while in C we start them at 0. So we have to translate them accordingly. And then we append this string to the append buffer. AB buff strlen of buff. So basically what we have done here is we have created an escape sequence which will move the cursor to the editor cursor position, which in this case will be ACY, ACX, where this is the row in terms of this is the here, this kind of height, and then this is the column basically. So that's the idea. And finally, we have to show cursor again. Show cursor again, and we can append this so it is similar to this one. It's just instead of 25L, it's 25 lowercase h. Show cursor. And notice here, we have appended a bunch of stuff to the append buffer, right? And we still have to write it. So we're gonna write to the stdout file now. We're gonna write the append buffer, AB with ABlen. AB with ABlen, and then we're gonna free this append buffer because it is, after all, only useful for us in this local context, so we want to free it after we are done. And this is a smart way of handling this kind of creation of the output. Why? First of all, we still have to define this last function, this editor draw rows. So before we are done, technically, we have to define this. So this is gonna take this pointer to the append buffer struct. But in general, what's the idea? Like already with this it works, by the way. And indeed, if you compile it, okay, let's see. Here it is not AB, but it is, we need a pointer to AB. So let's actually just do struct above ABP, and you're gonna be, okay, so that AB, ABP, okay, I mean, whatever, ABP, ABP. I mean, I guess we can just put the pointer to AB and whatever. I want it to be fancy, but maybe there's no reason to be fancy in this. So we have to have pointers to AB, of course. So that's the idea. Let's see if it works. SN printf, implicit declaration. SN printf. SN printf. Okay, it works. If I execute it, of course, I'm not gonna get anything, but it didn't do any errors, so that's good. Now, why didn't do anything? Because here, basically, all of these, we're not printing for content. This is just the skeleton, the basic structure. The actual content is in this editor draw rows. Because look at this. Here we are, hiding the cursor, moving the cursor to the top of the screen. Then now we should like print every row. And at the end, we move the cursor to the position where it should be, depending on the editor position, editor cursor position. And finally, we show it again. Okay, so at this point, we only need a single function and we are done for today's session, this editor draw rows. Now, this function should draw, it should be the main routine to draw what we see on the screen. Now, for now, we'll just draw an initial screen. In the future, we'll load files and things of the sort. So for now, we can just iterate, right? We can just iterate over the rows, which in this case is screen rows, y++. So we have y that specifies each row. So let's start with a very simple AP append with a single tilde. So here I just want to add this thing to the screen. And so after I've iterated through the rows here, I want to do this. So this is the content I do. I want to erase everything after this point, and I can do this with this cursor, with this escape sequence /x1b_k. So this tells erase everything from cursor to end of line because we don't want anything else. And then I want to append a new line, a b append, which I can do with /r/n 2, but this only if there's still something. So if screen rows -1, if y is slightly less than this, is strictly less than this, because if y is equal to screen rows -1, then I'm actually done. So write new line only when there are more lines to come, basically. So that's the idea. So with this, we should see something now. So let's go. Let's make it. Let's compile it. And wait a second, why? Okay, look at this now. Look at what we get. So let me see actually what's going on here. Here I have enable row mode init editor, process keypress. So let's say this process keypress. Here I have editor read key. So I need to read at least a key, I guess. I need to read at least a key. Okay. So when you immediately start the terminal, you don't see anything. But as soon as you type one character, you're actually gonna see this coming up, this tilde, all tilde in the rows, all tilde in the screen, basically. Now, we actually want to be a little bit more sophisticated than this for now. It's not going to be crazy sophisticated, but a little bit more. And so basically, okay, what we're going to do is we're going to add something. So we're going to say, if y is equal to a specific row, which in this case, I'm going to say screen rows divided by 3. Here, I'm going to print welcome message. Otherwise, I'm going to print this thing. So otherwise, I'm just going to print this thing. So the welcome message has to be like this. The welcome message has to be like, let's do welcome. It's going to be in this local buffer of 80. It's going to do, okay, let's do kilo editor version %s. But of course, this has to be created. So smprintf, we write into this welcome. We write the size of the welcome. And we write this with the kilo version variable here, kilo. Perfect. Now here it's going to give us the welcome len. At this point, we can say if the welcome len is greater than the size available, then welcome len is going to be truncated. So here we truncate the welcome len. Okay. Prepare welcome message. Truncate if necessary. So if necessary, we're going to truncate it. We're gonna, okay, let's do this. So AB append, AB welcome len. So in this case, we're gonna just add this welcome message by itself. Okay. We always erase everything, by the way. We always erase everything from the cursor to the end of line. That's good. Okay, let's compile. Let's do editor. Notice now we get this message, Kilo Editor version 001, but we want it not at this level, but we want it in the center of the screen. So we actually want it in the center of the screen, not like this. So to put it at the center of the screen, we want to add some padding, basically. We want to add some padding, so what do? Before appending the welcome message, we want to say, let's calculate the amount of padding that we want. Is screen calls minus welcome len divided by 2. So this is the amount of padding that we want, and these have to be always white spaces. So we say if padding, so we say if we have some padding, we're gonna append a single tilde, and then we're gonna decrease padding, and then while padding minus minus, here we're gonna append a white space. So add padding, truncate if necessary, and then just print the welcome message. Now at this time, I do make welcome, because here I forgot the character, it's welcome len, this thing, make editor, and now we have our text at the center. And this concludes this particular episode. So before closing, I'm gonna give a quick recap over what we introduced so far. So at the end of the second episode, now the loops looks like this. We enable raw mode, we initialize the editor, and we have this loop where we process the raw inputs and we print the raw output to the screen. Now we have introduced the editor struct, so we introduced this editor.h with the editor struct, which contains the cursor position and the position of the sides of the screen rows and screen calls, and also the terminal configuration in Orig Termios. We've introduced another struct which handles with the editor key, and we have written basically what we have written. We have written the init editor function, we have written these three functions that handles the read key, the window size, and the cursor position, and we have written the editor draw rows and refresh screens with respect to it by using the append buffer. And finally, we've written about the editor move cursor and the editor process key, which by the way, they should be in the editor section. So as you can see here, basically we can sort of like visualize these functions as follows. These are to handle the terminal. These are to handle the editor. These are to input, to do the input, to handle the input. This is like to handle the output, and this is utility functions to handle the append buffer. And so in the code itself, here we can see basically. So one thing that, by the way, we change is now in enable raw mode, we put at this at exit, which if you didn't know about it, this makes sure that when the program exits, this function is executed. This disable raw mode is going to be executed. Everything else is the same. Then we have the editor read key, which is used to read the escape sequence from the terminal. Then we have the get cursor position, which is used to obtain the current position from the terminal by using escape sequences, escape codes. We find the get window size to obtain the size of the terminal. This is the helper append functions to deal with the append buffer. This is to print the main content of the editor. For now, it's just simple like tilde. In the future, of course, we're going to write here the text lines of the editor. This is to do the refresh screen. And finally, these are to deal with the editor. So here we have the function to deal with movement, editor move cursor, the function to deal with a general key press, and the function to initialize the editor. So at this point, we are roughly at 300 lines of code. In the next video, we will see how we can put actual file content on the screen and how we can edit it. So as always, I hope it is fun. As always, I hope you get something out of it. If you want to support my work, there is a Patreon down in the description. And if you're interested in web security, I've created a course on web application security. So go and check that out as well. Thank you very much, and to the next video.